We're going to go through the Project of the Year winners from the previous year, and that's where they have a chance to come up and tell you what was so special about their project and field some questions. Of course, tonight we'll give the winners for the 2011 year. That'll be at the gala tonight. But first, I'd like to have the president of the AISC come up, Roger Furch. He's got to travel early this morning and get on to the next meeting, and I can tell you, in his position, he is very, very busy, and he has a lot of meetings that he needs to attend, and it was a real honor to get to spend some time with you last night and with your lovely wife, Nancy.
Thank you, Alan. And I just wanted to, I'm really not trying to hijack every agenda here, and even though I did say a couple things yesterday, I realized after I finished yesterday that I talked a lot about what AISC was doing. I didn't talk a lot about how AISC connects with SEIA. And a couple other things have been going on. Over the last 6 months, we commissioned FMI to go out and do a market survey. This market survey included 1,000 people that answered a questionnaire, and then we went out into various cities and did focus groups where either general contractors or architects stood behind one-way glass so we could observe what they were saying, but they didn't see our facial reactions or the times we were climbing out of the chair and wanted to come through the wall. And a couple things out of that really do impact SEIA, impact the erectors. The first that we learned, and we do these surveys about every 10, 12 years just to see where is the marketplace going, who's making the decisions, why are they making the decisions, why are they choosing steel over concrete, which is the answer we want them to come up with. One of the big changes that came up this time, and maybe it started 10 years ago, but it has been very evident now, is the general contractor is more influential and gaining influence as the architect is losing influence. And whether that's the general contractor working on pre-constructions, services, or whether it's the general contractor talking to the owner saying, hey, your architect doesn't know what he's doing. I hope there aren't many architects in this room. And I've got a better way. But I'm savvy enough to know, and actually I was reflecting on it last night. SEIA is celebrating its 40th anniversary. It was more than 40 years ago when I first walked on a job site and learned about plumbing a building and serving as a project engineer. So I've been there, I've been out there. It is the erector that makes the lasting impression of steel construction. And one of the things I want to work on, and I've talked to your leadership as I've been here, is how do we connect better between AISC and SEIA? What can we help you with? And if, as you have problems, and there's a lot of change coming, whether it's going to be laser scanning that's going to make parts of our tolerances get challenged even further, whether it's more BIM and IPD. There's a lot happening. I need to hear about it. I'm here to help you. I'm here to help it from the detailer to the erector to say, what can we do better to grow our industry and move forward? So I hope you've all signed up to come to our conference next month down in Dallas. We expect over 3,000 people, large trade show. On the other hand, if you have a comment, you have a problem on a job, you just want to say, hey, if AISC was doing this, it would help me. Send me an email, contact our Solution Center. So let's work together. Let's continue to grow the market share. We're at 58%, but I'm not happy until we get over 60. Thank you. Thanks, Alan.
Well, this year, only one of the winners from the previous year is here, and it's going to be the Peterson-Beckner team. Craig's going to give up a presentation on their project last year. It was the Texas Children's Maternity Center Bridge in Houston, Texas. What I'm going to do is try and wing the other two after he is done so that they can take as much time as they would like. Does that look like the right one there? That's us. And right on top. You're live.
Hello. As you mentioned, yeah, we won for 2010 for the Texas Children's Hospital Bridge. It was a very unique project, one we're proud to be a part of. To give you a little bit of overview of the project, it was a three-framed level so two walking levels, but a pedestrian bridge, elliptical that spanned over Fannin Street and connected the three main Texas Children's Hospital buildings. The maternity center, which is the new facility across Fannin, and the West Tower and clinical care facilities. It was about 800 total tons and 643 foot long with 4 permanent supports. The tonnage of the job and actually the framing itself wasn't what made the job very difficult. It was really the site conditions more than anything. Fannin is the major thoroughfare through the Texas Medical Center. It also includes the Metro light rail running through the median. It also, if you can see, there is an overpass on the top of that right picture. So that was a major grade separation. There were basements under all 3 buildings as well as major utilities, all of which added to very difficult site conditions that we had to kind of work around and limited where we could put cranes and lay down material. Another thing about Fannin is it had to remain open during main hours, and so all the project deliveries had to be taken at night, either during the week or on a scheduled weekend shutdown where we could work basically from 2 a.m. Saturday to 4 p.m. Sunday. So you had a very small window when you had complete access to the area. As I also mentioned, the 4 permanent supports, so there was several very long spans, particularly over the Fannin Street, which required some creative use of false work as well as large pre-assembled sections in order to bridge those gaps. There were very tight steel tolerances. We're connecting between 3 fixed points, and so everything had to fit perfect, or else when you got to the end, it wasn't going to work. So we had to pay very close attention to where we set things and the tolerances that we had. And if that all wasn't enough, the fabricator decided he'd had enough of this recession, and he closed his doors about 6 months prior to the start of erection. So we had to take all the material in our yard 6 months in advance and store everything. And as it kind of turned out, we found out that in their last move, they burned all the holes as opposed to drilling them, and all of them were oversized and incorrect. We ended up having to oversize match drill all the rest of the holes and upsize the bolts. All this prior to starting of erection, but we found that luckily we did find the problem before we got to the job. The bulk of this job was actually the planning phase. It was only about a 10-week erection duration, but we spent about 3 years planning for it. And we were fortunate enough that the general contractor recognized the difficulty of the job and brought us on board that early. As y'all know, probably a lot of times we get brought in later than we'd like and don't get as much input. They let us get on board very early, and so we were intimately involved in all the planning phase for the entire project. And the big part was the weekend closures. They're very particular about when we could shut down Fannin Street, so we had to plan around those, and also had to plan around the Texans football weekends. That light rail is a main transportation to and from the game, so we had to organize our weekend work on off football weekends. We had to plan for the false work locations. We obviously couldn't put it in Fannin Street, but we also had to avoid all the basement and tunnel areas for the surcharges they'd put on those. As I mentioned, the weekend closures we had to plan, 5 of which we required working 24 hours a day for those. I guess it was about a 36-hour period. And I mentioned all the basement and underground. We had to restrict our heavy cranes and equipment to 2,000 pounds a square foot. It required 2 layers of mats. And I guess to give you an idea of how many mats we needed, we had 144 truckloads. So I think in the first picture you can sort of see in the right that whole mat runway for the red M250 there. We had to have a lot of mats to try to avoid all the underground conflicts. Material storage was another problem. We could barely fit the cranes in the areas we needed. We certainly couldn't take any extra material. So all of them had to be on time. And when I say on time, I don't mean like, you can deliver it tomorrow morning. I mean like it needed to be here at 2:14. I mean, they were very, very particular about when we could take the material. And on the bright side, we did have all the material in our yard, so we kind of were able to control that. So that probably helped. Another thing we try to do is we got creative and utilize the roof of the maternity center, which was the new facility they were building. We had to come up with some proper, shoring and mats to spread the load, but we were able to put a couple of pre-assembled sections on top of there. One of the problems was when we laid it out, we could find a way to spread the load properly, but when you tripped it up, you ended up inducing some point loads again, so that was something we had to deal with, but it was useful to use that area because we didn't have much else. And the last thing we had to do is a lot of critical lift planning. Most of these were pre-assembled, fairly heavy sections, but multiple point and multiple crane coordination, especially when you're closing the spans. You had two of them coming together, so we had quite a few critical lifts that were involved. To give you a little bit of an idea, kind of hard to see, but the pink, there's 4 pink false work towers. Those were the locations of the towers. This was what we called the west section. We built that first, then the south span and the north span. And these middle sections are the big spans over Fannin that we ended up using 2 cranes to fill in at the end. This kind of gives you an idea of the site. We used a Kobelco on the top right, CK2500. We had to bring in a 500-ton hydro during portions on this corner over here. And this was an M250 that, for the most part, stayed over here. And then during the critical lifts of the north span, we had to mat him over to get him over here to make this final span. And this is an example of the critical lift. You can see all the mats. This is particularly one of the ones where the M250 did have to walk all the way over to set a final box section. But it involved more than just the rigging and the crane capacities. It involved all the matting required to avoid all that underground work. And the last thing I want to show you about the planning phase was this is a diagram we just came up with for spreading the load on top of the maternity center for storing the material. Just another thing that we had to kind of deal with. So that was. Now the execution, as I said, is only about a 10-week erection duration, so that part of the job was not certainly not the bulk of it, but it still was no piece of cake. The west section we built, we stick built it. We actually were able to utilize the GC furnished tower crane, the crane that was building the maternity center. And then we used our crane for the north half of it. But the issue with the stick building was obviously this is a bridge, so there's no anchor bolts. There wasn't any place to fix the point. You had to set it up there, shoot it in with a total station, get it exactly where you needed it, then temporarily fix it to the maternity center, tie it in, and keep it from going anywhere. Because again, you had the tolerances and locations of the material were very critical. So every one of those pieces had to be located and tied in before you can go to the next one. After we built the west section, we went to the south span. Here we pre-assembled box sections, anywhere between 78 and 103,000 pounds. We did use 2 false work towers right on the edges of the Fannin Street where we could avoid blocking the street. That left a pretty good span in between that we had to fill in. So the last 2 pieces you'd fill in with 1 crane each and fit them in neat. So again, that's where all the tolerances really became critical on those last fill-in. When you're completing the span, it was very tight. Here we used our M250 as well as that's where we brought in the 500-ton hydro. You can see on the right picture, that's where we're completing the span with the 2 cranes. And then we repeated a very similar procedure on the north. And again, here you can kind of see a better example of those box sections. They were all 3 levels with the deck on them and the perimeter fall protection cables pre-installed to help our guys get up there and work safely. You can also see some of the netting that we had to use to prevent any dropped objects onto Fannin. This again was a very major thoroughfare, so we had to protect the general public as well. Let's see, this is a time lapse, kind of give you an idea of the progression of the job and from a 3D, from a bird's eye view. You see quite a bit of night work. That was all that weekend. That was pretty much it. But it was a very unique job, one we were certainly proud to be a part of, and appreciate the project of the year. And that's pretty much what I have. If anyone has any questions, feel free.
Make any money?
We did. I'd be embarrassed to say it here if we didn't, but we did. So it was a good job for everybody involved. I think it was very safe. The owner was pleased with what they got, and we certainly were happy with our end of the deal. So it was a good job all around. We did. Again, the planning phase was this job, and we spent months going through and developing these mat layout diagrams and making sure. And we worked with Walter P. Moore, actually was the engineer of record and our erection engineer, which was helpful. And so they really helped us to be conservative with our mat placement and make sure that we weren't going to damage anything. Because part of that stuff, they weren't even sure what they had under there. Some of these undergrounds, they've got old drawings, and so they had to be conservative about it. But that's why we had the 2 layers of mats, and then sometimes we used 2-inch plate on top of that to really make sure. So we had quite a bit of matting to spread that load. We were very fortunate. We were very fortunate that again, because we were brought on at such an early stage, we actually had some input into the design, and we, as many of you probably are aware of or are familiar with, we prefer the bolted option. So the design was such that the fabricator made tree columns with stub outs welded, and the connections between them were bolted. So we were able to either set tree columns or actually set the box sections, but all the framing connections themselves that we would make in the field would be bolted. So that was very nice. Again, as I mentioned, a lot of them were designed to be, I think it was 1 1/8 inch originally, and then the fabricator, the way it ended up working out, we ended up having to match drill them all and make them 1.25 inches. But the bolted option was certainly one we appreciated.
If you ever do a pedestrian bridge over a state road, ask that question. It costs us money.
David, repeat that so everybody can hear that, because that is very critical, I think.
Okay. We did a pedestrian bridge similar to this, and it was over a state road, and the state engineer cherry-picked some of the provisions out of their code to apply to the pedestrian bridge, which one of the provisions required it to be fracture critical welding, and which is, somebody with AWS help me out, AWSD 1.1 table B. Anyway, it's a much tighter tolerance on the amount of inclusions and whatnot in the weld, and Bill Brinsky might remember it. I don't know, but it was a tough job, and so you need to be aware that the state DOT can't affect it, even though from a design standpoint, the pedestrian bridge there was no reason for it to be fracture critical from a practical standpoint.
Any other questions? Well, thank you very much.
Thank you.